This is geometry, working on Unit 4, the triangle sum theorem. When we look at our triangles, triangles are actually made by sides that are lines, and we can create these angles on the inside called the interior angles. The angles on the inside of a triangle are called interior angles. Now, more trickily is the exterior angles. If you extend the side of the triangle, it creates this angle on the outside. It's got to be an extension of the side, and the angle that is formed is called the exterior angle. Now, there are properties to expect about these different angles. What's true about the interior angles? And in the future, we'll talk about what is true about the exterior angles. The triangle sum theorem. The triangle sum theorem says that the sum of the interior angles of a triangle is always going to be 180 degrees. If we take a triangle and we're going to label each of these angles 1, 2, and 3. Those are the three angles of our triangle. If we take our triangle and tear off each of these angles, we have what used to be our triangle but has no more corners on it. What we're going to look at is what happens when you put all the points together. And when we put the points together of the three angles, no matter what triangle you possibly make, you'll always see that they form a straight line. So those three angles are always adding up to 180 degrees. So the sum of the measures of the interior angles of a triangle is 180 degrees. The measure of A plus the measure of B plus the measure of C adds up to be 180 degrees. Some other properties of triangles is how we name them. Right here, we're going to name the triangles only based on their sides. We're going to talk about their side measures and what we might call the triangle. So here we're going to say that all the sides are different. So there's not a lot of choices we have in terms of drawing this, but it would look something similar to this. We put a tick mark to represent each side that is different. The 1 tick mark side is different than the 2 tick mark side, which is different than the 3 tick mark side. And this would be called a scalene triangle. All three sides are different. At least 2 sides are the same. Here, these 2 sides seem to be pretty close to the same. So if they're exactly the same, then we can put a tick mark on them. But notice how they're different than the third side. It would also be considered isosceles triangle if all 3 sides were the same. At least 2 means that 2 sides are the same, or three sides are the same, these are going to be called isosceles triangle. Now, just like in a polygon, a square is a polygon, but it has four sides. A triangle is a polygon, it has three sides. So a polygon's not very specific. Isosceles is not very specific here because it could actually be looking like two different shapes. So typically, if they are all the same, we're going to call that an equilateral. I ran out of room, but equilateral. It's not spelled equal lateral, it's equilateral. And all three sides have to be the same. So yes, this is considered an isosceles triangle, but the most specific name would be equilateral. Looking here, we're going to talk about naming the triangles based on their angle measure. So we're going to look at a triangle that has one obtuse angle. Well, a triangle cannot have more than one obtuse angle. An obtuse angle is greater than 90. So if we're going to follow the rules that we learned up here about a triangle is exactly 180, then you can't have two angles more than 90, because that would automatically be more than 180. So if you have one obtuse angle, and two acute angles. If we have that, then we're going to have an obtuse triangle. An obtuse triangle is going to have exactly one obtuse angle, but it will also have two acute angles, because it still has to add up to 180. If you have a triangle that has a right angle, that is going to be one right angle and two complementary angles. That means two angles that add up to 90 degrees. This will be called a right triangle because it has one right angle. You can't be a triangle with two right angles, because two angles would add up to be more, or would add up to be exactly 180, and you haven't talked about the third angle yet. So you cannot have a triangle with two right angles. An acute triangle is going to be a triangle with three angles less than 90. All three angles are less than 90 degrees. This is going to be called an acute triangle. These names are probably pretty familiar from previous classes. We have scalene, isosceles, equilateral. That's naming it by the side lengths. Obtuse, right, and acute are naming it by the angles. Sometimes we could name a triangle based off of both of those categories. So here we're going to try these. We're going to classify each triangle based on the side lengths. Well, side lengths are interesting. There's a couple properties with side lengths. The first thing to realize about side lengths is a triangle, of course, needs 3 sides. You can't make a triangle with 4 sides. So a triangle always has 3 sides. But can it be any side length? And if you look here, some side lengths won't even touch. So they don't even make a triangle. So there's got to be some property that's happening where the side lengths have to be of certain length, certain numbers, for it to even make a triangle. So typically what we say are the 2 small sides have to add up to be longer than the third, the longest side. Because if they don't add up to be longer than it, then you're not going to get the teepee type shape situation. So here it kind of looks like the 2 numbers are adding up to be more than the longest side. But if I go back and I connect it back here, it isn't in this case. So we would have to shorten up that red side to be able to make a triangle. So that's one property. The 2 small sides have to add up to be greater than the longest. Okay, otherwise we're just looking to see, are they all different? Are they all the same? Here we have 3 angles that are all different. We have all different lengths. So this is going to be called a scalene triangle. On the next one, we see that the 2 small sides are also adding up to be more than the longest. 7 plus 6.5 is more than 7.3, of course. So yes, this makes a triangle. All different lengths. So this is also going to be scalene, because all the side lengths are different. In this case, the 2 smaller sides add up to be more than the longest. So yes, this could actually make a triangle. And we recognize that 2 sides are the same. So that's going to make it an isosceles triangle. Because exactly, in this case, exactly 2. But remember, an isosceles triangle could have 2 or more sides the same. So we look here at the last example, and we have 2.4, 2.4, and 2.4. Of course, the 2.4 plus the 2.4 adds up to be more than the third side, more than what might be considered the longest side. So yes, these are actual lengths that a triangle could be. All equal lengths. You could call this one isosceles, but a better name for this would be equilateral. Now we're going to move down and talk about naming a triangle or classifying a triangle based only on its angle measures. We're just going to talk about angle measures here. So we're looking here at the first one. We see a triangle with a right angle. So since this is a triangle with a right angle, this is going to be considered a right triangle. Notice in this example, the two other angles are the same measure. They could be the same, they could be different. It could be 50 and 40. It could be 30 and 60. It could be a whole bunch of different lengths. 75 and 15. But in this case, they happen to label it as 45-45. It's still a right triangle. It can only have one 90-degree angle. This one is a triangle with an obtuse angle. Okay, if you have an obtuse angle, then you're going to have two acute angles. But it does have an obtuse angle in it, so it's called an obtuse triangle. Here it gets a little trickier. I see this is a 25-degree angle. This is a 73-degree angle, but I'm not sure what that missing angle is. You can't always believe the picture, so you've got to do the calculations. So what I know for sure is that all three angles are supposed to add up to 180. They will always add up to 180 for a triangle. So 180 minus 73 gives me 107. Minus 25 gives me 82 degrees. So this angle out here is 82 degrees. So this is going to be called an acute triangle, because all angles, all three angles, are less than 90 degrees. Here's an example of having 21, having 36, and having this additional angle. Now it looks like this additional angle is small. No doubt about it. It looks acute. But if you start looking at these measurements, maybe it's not drawn to scale. So we need to do our calculation to figure out what this angle is. So again, if we have 180 degrees and minus the 36, then I get 144. Minus 21 more gives me 123. So this angle here is actually 123 degrees. So what that would mean are these angles are just actually too big. This isn't a 21-degree angle. If this was 21 and this was 36, it would have to be cutting back. So you would get an obtuse angle to be drawn. This is an obtuse triangle. That brings us down to our last few that we can solve in a very similar method. We have three angles of this triangle. We know two of them, we don't know the third one. We know that all three angles are supposed to add to be 180 degrees. So these two are going to add up to be 54 degrees. And we subtract the 54 to get 126. And we will divide out the 126 to get 42 degrees. So the x value, well, it's not degrees, it's just x is 42. The angle number is 3 times x. 3 times x, we learned, was 126. That's a degree value. So find the angle that's missing, the missing angle value. That's 126 degrees. Here we have expressions for some of our angles. So still, we set it up the same way. We say 4x minus 5 and 3x plus 5 and the 40, they all add up to 180 degrees. The negative 5 and the positive 5, we don't say plus 5 because they're on the same side of the equal sign. They just cross each other out. You're adding and subtracting the same amount. They're going to reduce each other. 4x's and 3x's is a total of 7x's. And we subtract. So 7x equals 140. So when we divide, we get 20 degrees. Well, that's the value of x, 20 degrees. The value of the angles would be 4 times 20 minus 5. That's 80 minus 5, which should come out to 75. 3 times 20 plus 5 is 60, plus 5, which is 65. Together, the 75, the 65, and the 40 are going to make 180 degrees. Okay, the last one is somewhat of a word problem here. It talks about a triangle, and I'll just draw a random triangle in here. One of the angles is 44 degrees, so I have a 44 degree angle. Of the two remaining angles, one angle is 3 times, that's the key term there, 3 times the measure of the other. So 3 times as big, you're going to have an angle worth x, and you're going to have an angle worth 3x. One angle, the other one is 3 times that amount. We don't know the measure of either one of them. So we have 3x plus x plus 44, making our 180. That makes a total of 4x. And we subtract our 44 across to get 136. That's going to go in there 3 times, and that's going to go in there 4. So 34. So we have an angle worth 34, and we have an angle worth 3x, which would be 3 times that amount, which is 102.